In this video, I will talk about characteristics of pyramids, prisms, and how to determine the bases of both types of shapes. Okay, a pyramid is a polyhedron, which basically means many-faced. And these faces are polygons, like triangles, squares, and so on and so forth. A pyramid has a single base that is a polygon. For example, that looks like a parallelogram, and that one is a hexagon. The third part of a pyramid is that it has lateral faces that are triangles formed by connecting each vertex of the base to a single point, which we call the apex of the pyramid. And the apex could be above the pyramid or below. Now, the lateral faces do not need to be congruent. For example, this one here, all of the four lateral faces are triangles, and I don't think they're congruent. The second type we will talk about is a prism. A prism is a polyhedron. What makes a prism different is that it has two congruent parallel bases that are polygons. So in this case here, we have two hexagons that are congruent and are parallel to each other. The third characteristic is that the bases are connected by lateral faces that are parallelograms formed by connecting the corresponding vertices of the two bases. And these lateral faces can also be rectangles, rhombi, or squares. Okay, so you can see right here, each hexagon is connected. In this case here, probably rectangles going all the way around. Okay, let's start with our activity. So in this activity, what we're going to do is we're going to sketch or shade in the base, and then we're going to name the particular shape. Okay, so the first one, I think it's pretty obvious this is not a pyramid. Now, what is the base? Now remember, with a prism, it has to have two congruent parallel bases. Okay, and for letter A, that's actually the front triangle and the back triangle. Okay, so these are the bases, not what's on the bottom. So a lot of students think the way the drawing is that whatever shape is on the bottom is what the base is. But remember, for a prism, the bases are congruent polygons that are parallel to each other, connected by parallelograms. In this case here, the two triangles are congruent, parallel, and connected by rectangles. Now, you can see why this rectangle down below is not a base, because directly across from it is not a congruent rectangle that is parallel to that. Both of these rectangles on the left and right just go to they just meet. Okay? So, base makes sense in the real world when we have gravity. Like the base of a building is the bottom. The base of my lamp is the bottom. But in mathematics at the high school level, we're going to go in general. Imagine this shape just floating in space and there is no top or bottom per se. Then what would be, by definition, the bases? Okay, now we name the prism based on the base. So in this case here, we have triangular faces. So we're going to call this a triangular prism. Okay, letter B. Definitely not a pyramid, so it's a prism. Now, the faces that are congruent, definitely the top and bottom in this case here, but once again, don't get stuck on it has to be the top and bottom. And the perspective is kind of hard to tell, but it's probably rectangles that are directly connecting. So we have a hexagon on the top and bottom because it's got 6 sides. So we're going to shade in the top and bottom. And there are 6 rectangles, 2 on the right, 1 in the back, 2 on the left, and 1 in the front, that are connecting those shapes, the bases. Now, this is a hexagon base, and so we call this a hexagonal prism. Letter C. The only congruent sides that are parallel to each other are the top and bottom in this case. They each have 5 sides, so those are pentagons. and there are 5 rectangles that connect the pentagons. So we call this a pentagonal prism. Once again, a pentagonal prism. Letter D. Letter D actually has 3 different pairs of sides that could be bases. For instance, it could be the bottom and the top because they are both rectangles and they're connected by parallelograms all on the side. So we got 4-sided bases, each connected by, in this case here, it looks like squares on the front and back, and on the left and right, some rectangles. But those aren't the only bases. It could be the squares, the one in the front and one in the back, because these 2 squares are congruent and parallel, connected by rectangles. And it could also be the right side and left side. It could be the bases because they are connected by rectangles and squares. I'll just call this one in general a rectangular prism. Letter E. Obviously a pyramid. Now the base could be the bottom because we have a triangular base and all the other 3 sides, the left side, the right side, and the one in the front, all go to a single apex. But in this case here, it could be any of them. It could be the left side. If I were to shade in that left side, then the front, the right, and the bottom all go to a single apex. So just to be different, I don't know, let's shade the right side. So this face on the right, that means the front, the left, and the bottom all go to a apex pointing this way. We call this a triangular pyramid. Letter F. Obviously a prism, so we're going to shade in the bottom and the top because they are congruent and parallel. Now these are octagons, and so they are connected by 8 parallelograms, which in this case here are probably rectangles. Perspective is just kind of weird. I mean, I guess they could be just parallelogram. It looks like it's actually slanted, so maybe it truly is parallelograms. Now, so this we're going to call an octagonal prism. Okay, because those are the bases. Now, some students might say, hey, Mr. Roeder, assuming that these are regular octagons and these are rectangles, then some students will say, but hey, guess what? The front rectangle is going to be parallel to the back rectangle, the one directly opposite from it. And you're absolutely right. The front rectangle and the back are parallel, and they are congruent. However, those are not bases. Remember, the bases of a prism must be parallel congruent, which we have, but connected by rectangles. Well, this 4-sided rectangle has one side touching an octagon, and the octagon is the only shape that's connecting the 2 rectangles. The side of the rectangles are not connected directly by another rectangle. In this case here, you have like 3 rectangles you got to get to before you get there. Okay, so remember, it's got to be 2 congruent parallel bases that are connected by parallelograms going all the way around. Okay, this is a good time for you to pause the video and try on your own the next 6 examples. Okay, I'm going to assume you pause the video and try those on your own. So here are the solutions to the bottom 6. Letter G. I call that a trapezoidal pyramid. I think that the base is a little hard to see given the perspective. Maybe you said rectangular, maybe you said square, parallelogram. I'll accept any of those answers. This one's kind of hard to see. Letter H, pentagonal pyramid. I don't know why I capitalized the P's here and I didn't do it the rest of the time. LOL. Okay, letter I, pentagonal prism. Letter J, hexagonal pyramid. Letter K, a rectangular prism, if I use the top and bottom, or the left and right as the bases. Or I call it a square-based prism, possibly, assuming that the left and right side are squares. And last one, letter L, is a triangular prism. I hope you guys did well on those.